Hey everyone. So we are moving away from the word problems just for a little bit though. And we're basically going to be using the derivative to better understand functions. So understanding how to find the minimum and maximum values over an interval. So instead of having our negative b over 2a and using the calculator, we have other ways of finding the min and max. So I want you to sketch those, see if you remember how to graph those. So for the first, just kidding. All right. So we have my zeros are at 5, -4, and -8. Let's see. And remember when I taught these to you guys, most of you at least, it was that we were like, what happens as x gets really big? It was really a limit. What's the limit as x approaches infinity? Well, I have x, and x squared, so that's positive infinity, so it's going off to positive infinity. And then it's a polynomial, but because of that x squared, it's a double root at -8. So that's that graph. And then for the second one, we have 12, -9, and 0. The limit as x approaches infinity for this one, though, we have it is negative infinity. So going down, and it's a nice smooth graph. Those are definitely some rough sketches. All right, so there's a lot of writing in this lesson, so pause, write this down. So in absolute or global extrema, usually I say absolute, but you see global also. So f is defined on an interval. So this is important. We're talking about an interval. So it's not on the whole domain. Where there is a number u in the interval where f of u is greater than or equal to f of x, there is an absolute maximum. This is just a really fancy way is when you have an interval, and it has to be a closed interval it's equal to, there is always an absolute maximum, always. And there's also an absolute minimum. That will always happen on a closed interval, right? It has to be a closed. If it's an open interval, that's another story. So we call these, a lot of times we'll use the phrase absolute extrema. So you'll see extrema a lot, and it's just like the all-encompassing word for max and min. All right, so the extreme value theorem is basically what I just said. If a function is continuous on a closed interval, then f has to have an absolute maximum, absolute minimum. So it doesn't matter what the function is, as long as you have a, say it's this, if I have a closed interval from here to here, so my minimum might be down here, but my maximum's on an end. Because it's a closed interval, you have those endpoints which makes it so that it has to have a max. All right, a critical number. A critical number, we're going to use this a lot, is, and we've been finding this already, when a function f, a critical number of function f is a number c in the domain where f prime of c equals 0. So that's our horizontal tangent line that we've been talking about. But here's the other one that's really important that kids tend to leave out. It's also where the derivative doesn't exist. So we're taking the derivative, setting it equal to 0, just like we've done with our horizontal tangent line. But then we're also finding where the derivative does not exist. All right, so let's do these two. So we're going to find the critical numbers. So pause the video. You're going to take the derivative, set it equal to 0, find where the function is 0 or does not exist. So for this one, f prime, 3x squared minus 6x plus 9, set it equal to 0. I'm going to factor out a 3. Did I do that wrong? Yeah, I did that wrong. I'm going too fast. That's 12. Eraser work. So then that's a 4. That's what I get for trying to do this too fast. All right, so then I factor x minus 1, x minus 3. So my critical numbers are x equals 1 and x equals 3. All right, so those are my critical numbers. They could be max or min values, but we don't actually know. All right, so for the second one, take the derivative. Now this is another, remember I kept saying, you should memorize this, you should memorize that. Well, one of the things I told you to memorize was the derivative of 1 over x is negative 1 over x squared. So that when I do this one, 1 over x minus 2 is just negative 1 over x minus 2 squared. Now this function will never equal 0. However, remember the critical points are also where the function is undefined. So if we set the denominator equal to 0, x equals 2 is our critical number. All right, same thing, find the critical numbers. All right, so g prime is cosine. So cosine of x equals 0 at pi over 2 plus pi k, where k is an integer. Or if you want to be fancy, you can write it as k, and then that weird e belongs to the integers. That's a symbol. As a weird z with an extra line on it is the integer symbol. Okay, 4 is the hard one. Are you ready? If you're not, I don't care. We're going to do it anyways. This one's the tricky one. This is the hardest problem in this whole lesson. All right, so I'm going to take the derivative. It's a quotient rule. Derivative of the top. 2 over 3, x minus 2. 2/3 minus 1 is negative 1/3 times the bottom minus the top. Derivative of the bottom is just 1 all over the bottom squared. Now here's the problem. When we were just finding the derivative, it was like, whatever, we're done. But now we need to set this equal to 0 and solve. So we need to find a common denominator. So I'm going to ignore that x squared for a minute. I'm going to just start by rewriting these. Okay, so I'm going to rewrite this. So when I rewrite that, I get 2 over 3. Negative 1/3, that's the cubed root of x minus 2. And then times x, I'm going to throw that x on top. Right? So this one on top and this one on top. The 3's on the bottom. Negative 1/3 is 3 on the bottom from this one, and then the cubed root of x minus 2. Minus the cubed root of x minus 2 squared. Right, and that's all over x squared. But I'm actually going to erase that. So now, in order to solve this, we're going to find a common denominator. Right? So this left one is a fraction, so I'm going to put this over 1. So the common denominator is this guy. So I'm going to multiply by 3 times the cubed root of x minus 2, and then 3 times the cubed root of x minus 2. Right. So my whole denominator is 3 the cubed root of x minus 2. But now, let's see what we get here. So I have this 2x minus. Now, what do I get when I multiply these guys together? Well, this is to the first. So what we end up getting is the cubed root of x minus 2 to the third. So those are inverses, they cancel out. So we just get 3 times x minus 2. So when we did that, the cubed root ended up going away, right? This is x minus 2 to the 3 over 3, which is just 1. So now I'm going to simplify. So I get 2x minus 3x plus 6. I'm running out of space. I'm going to erase something. I'm going to go back up to the top and erase. All right, we don't need to do cosine. All right, so let's go up top. So we have negative x plus 6 over 3 times the cubed root of x minus 2. And then that whole thing is over x squared. So remember that x squared, we just move it into the denominator. Eraser. Work. All right, so that, again, like I said, this is the hardest problem in the whole lesson. This is one of the harder things we do. All right, so we end up with negative x plus 6 over 3x squared, the cubed root of x minus 2 equals 0. So now that we have that, we can decide what our critical numbers are. So set the numerator equal to 0, x equals 6, and then set the denominator equal to 0. So we get x equals 0 and x equals 2. So those are our critical numbers. That was rough. We're going to do it again. We're going to do the problems like this a lot because they're very common. Okay. Locating extreme values. Let f be a function that is continuous. Again, the absolute max value and absolute minimum value are the largest and smallest values found among the following. They're either at the critical numbers or at the endpoints. So basically, to find the extreme values, take the derivative, set it equal to 0, find your critical points, and then use your endpoints, plug them all in to find your biggest and smallest y value. So we actually already did this problem. So look back. What did we get when we set this equal to 0? We already did this problem. We got x equals what? We got x equals 1 and x equals 3. Right? It was 3x squared minus 12x plus 9. We factored. So now what we're going to do is we need to find the greatest and least y value. So I'm going to plug in f of 0, my endpoints, and my critical values. And actually, I'm going to ignore the 3 because the 3 is not in the interval. We don't need to plug it in. Right? So we're only focused on within the interval. All right, so plug into the original function. So I plug in here. F of 0 is just 2. F of 2, let's see, that's 8 minus 6 times 4, 24, plus 18 plus 2. So it's that negative 4, I got 4. And then 1 minus 6 plus 9 plus 2. So that's 11, 12, I got 6. All right, so my absolute max is at x equals 1, and my absolute min is at x equals 2. Now, here's the thing. You have to pay attention to the wording. These are your absolute max and absolute min. Now, let's say it said absolute max value. The absolute max value is 6, the y. The absolute minimum value is 2. So if you see the word value, that means your y. Right? Anytime it asks for the max value, that's your y. If they just ask for the max, you're going to put your x. All right, last one. So just like before, we're not going to redo this problem. What did we get for our critical numbers? So we look back and we got x equals 6, x equals 0, and x equals 2. Now, one of them we're not going to use because it's not in the interval. So remember, we're only going from 1 to 10, so 0. And that's kind of important because when you're finding absolute, it has to be continuous. This function is not continuous at 0. It's not in the domain. So it's important that that the problem is choosing 1 to 10. All right, so now we're going to find f of 1, the endpoints, and then the critical numbers, f of 6 and f of 2. So plug those in. Do not use a calculator. We want to try to figure these out without a calculator. So the top one, we get 1 on the bottom, the cubed root of negative 1 squared, so we just get 1. 10 on the bottom, the cubed root of 8 squared. The cubed root of 8 is 2. 2 squared over 10, that's 4 over 10. And then 6 on the bottom. The cubed root of 4 squared. I don't know the square root of 4 squared. let's see, right? I did that right, 4. So that's the cubed root of 16 over 6, so whatever that is. And then 2, we just get 0. All right, so we definitely know that our minimum, this is our absolute min. All right. This is less than 1. Is this less than 1? The cubed root of 16. Well, the cubed root of 27 would be 3 over 6. So this is definitely less than 1. So this is our max. So as long as you don't really have to do a lot of like math, as long as you can convince yourself, okay, this is my absolute max, this is my absolute min. When you have these weird fractions without a calculator, as long as you can convince yourself that, okay, I know that this is the answer, like I know that the cubed root of 16 is going to be less than 6, so this thing is less than 1. That's all that really mattered, right? Because the cubed root of 8 was 2. Cubed root of 27 is 3, so I definitely know that that's less than 1. All right, there's your homework. Please do this homework before you watch the next video. I want you practicing this, so do this homework today, and then maybe tomorrow watch video 43 and do that homework.